Okay, so yesterday we cover a different topic about we cover the secret in detail and config map. So today we have to look into the concept of assigning the pod with some specific node. So if you search on Kubernetes documentation, you can see the assigning pod to node. So far, what we did, we just hand over all our requests to Scalar, and Scalar decide where the pod will run. So the only one thing we did that bypass the Scalar by using the static pod concept. And in that case, we can directly schedule a pod on specific node. But there are other concepts too. For example, that concept is only for the control plane related services for ETCT, API. All those are running as static pod. But for the application workload, sometimes we have to decide either on which node we want to uh, we want to run our workload. So if I draw a diagram, so you can get the idea here better. Just like if we have these three worker nodes, and you want to schedule this pod on some node. So Scalar by default will look into the load on different nodes, and then the Scalar will place this pod on different worker nodes. But in practical life, maybe your one node having more bandwidth, or maybe your one node having uh, specialized hard drive. Okay, just like this is my worker one, and it has SSD storage. Okay, this is my worker two, and it has, for example, GPUs. Graphic card is installed on this worker two. And this is my third worker node, and mm, it has more memory. Okay, so when you will schedule this pod, so you want to schedule this pod directly to the host that has more memory, or you want to run this pod with the GPU functionalities. Maybe your application need GPUs. And if you need the high disk IOPS, so you will schedule this pod on SSD based worker node. So in that case, uh, Kubernetes provide us different functionalities. Uh, these are assigning pod to node. So nodeSelector we can use, node label we can use, and the concept of affinity and anti-affinity, nodeName. We can use these concept to schedule some pod directly on some node. So for that reason, what I will do, we can label in Kubernetes. Every object has a label. Just like pod we create the service, uh, we create whatever resource we create, it has some specific label. Similarly, our worker nodes has by default some labels, and we can assign our own labels too. So on this node, I will make a label something like disk is equal to SSD. Okay. Here I will make a label something like uh, compute is equal to GPU. Okay. And on this one, I will assign something memory is equal to high. Any key value I can assign as a label to my worker nodes. If I show you how you can see the current labels by default assigned to worker nodes by Kubernetes cluster. This is my master node. And I think kubectl get nodes. So I'm directly jump into my master node. So I am using kubectl get nodes, and I have 3 nodes. And if I do something like hyphen show labels, so it will show me the labels associated with each node. So these are the default labels assigned to this worker node and master node. Okay. But I can add my own labels too. And on the basis of label, I can decide the scheduling of pod on those specific worker nodes. Okay, so if we go to the documentation, so first of all, I will show you there is a concept of node name. So node name is more direct from the node selection than affinity concept we have not discussed so far, but node name is the way that we can use this keyword directly in our manifest, and we can directly define the name of the node. It is not a concept of labeling, not based on label, but directly we can define the name of the node. And on the basis of the name of the node, that pod will automatically be scheduled on that specific worker node. Just like this, we just have to write node name and then name of the node. So that pod will schedule there. If we do the same for the deployment, for the replica set, for stateful set, so all the pods will schedule on that specific node. We cannot do this for a daemon set, because daemon set concept is different. It is designed to assign the pod to different worker nodes. So let me quickly go to some deployment I created earlier. This deployment I have, and here I have six replicas. And in the specs section, I can make a node name in parallel to container. Yeah, this here. Node name, and my node names, I want to schedule it on worker node 2. So all these 6 replicas must be on worker node 1. kubectl apply -f and kubectl. I think it was in which it's in the dev namespace. In the dev namespace. So ctl get pod -ndev -o white. You can see all the pods are scheduled on worker node 2. If I do the kubectl scale deployment, b app is the name of the deployment, and replicas to 10 in dev namespace. And if I get the pod, you can see all pods are only scheduled over worker node 1. It's mean we instruct our scheduler that only throw this load on our worker node 2. Okay, you got the idea? So this is the one way to assign the node to some specific worker node. Okay. So then next thing that how we can do this based on label. So based on the label, we can also define the label. So if we want to do something based on node, so then we can use this for label based. So we can use nodeSelector. We can use nodeSelector, and with the nodeSelector, we can define the label we associated with our node. So first of all, I will look into the nodes and hyphen show labels and kubectl label hyphen help. So kubectl label we can use to label some node with some key value. So if I want to do label node, so then I have to provide the name of the node, or I can directly label pod. So let me try first with the node. Uh, so now my worker node 1 is labeled like disk is equal to SSD. And the second worker node, I can do something like memory is equal to high. I do a kubectl get node hyphen show labels. So you can see the label is added to my node. Disk is equal to SSD and memory is equal to high. Now based on these labels or existing label I can also use, but those are for the Kubernetes cluster management only. We can use those too, but those are not like I mean as like according to our requirement. So we added our own. So now we have to make a manifest that will decide based on the on these labels to schedule the pod on some specific worker bot. Okay, how you can unlabel? Just like I did the label node memory high. If I again do this label, I think to unlabel kubectl unlabel, I don't think so. There is something like this. Uh, unlabel is nothing. There is nothing like unlabel. So I think there was. Just want to see the how to remove the label. Yes, you just need to add a hyphen. By removing a label bar exist, just we need to add a hyphen at the end and it will remove that label. So for example, I can also set something like this memory, or I can say disk slow. Okay, so I can use disk is equal to SSD. I don't know exactly, but it we are using a hyphen to remove the label. Let me check that in the documentation. Uh, label and label note. I don't know, just leave it. But there is a way to remove the label. But so far, what we did, we just uh, assign a label to our node. So now I have to schedule pod based on this memory is equal to high and disk is equal to SSD based decision. So for that reason, I can use nodeSelector. So in my manifest, kubectl get deploy, I think I did in dev namespace. So let me delete. In my deployment, now I am going to change node name with the nodeSelector. And then with an indentation, I can define like disk SSD. So my disk SSD is, I think, on all my worker node 1. This is my worker node 1 disk SSD. So you can see all the pods are now scheduled based on the label. And I can also add multiple labels. For example, I want to make a group of worker nodes, and I want to schedule those worker. For example, I have multiple 10, 15 worker node of cluster. And I make a group of different worker nodes. I only want to assign these pod to those nodes only, those who have only high memory and disk SSD, not to the worker node those are labeled as GPU or anything else. So in that case, I can assign multiple labels. So in that case, I can do here memory is equal to high. So why they are pending? Because let me check this. Describe pod. Failed schedule, default schedule, 0 variable, one node, untolerated. Okay. Yesterday, I think I did the taint, and I don't know, I removed the taint. kubectl describe. Describe node. One. Node 2, it is not tainted. Okay. I think I in my deployment, I add something. I think I need to delete this deployment. Okay. So this concept is actually not based on the group. I mean, both the label should be on the same node. That's why it is in the pending state. So why these all pods are in pending, if I go into the concept I gave you was not like this. Mean I cannot make that decision based on labels on different worker node. All the labels must be on the same worker node. So now whatever I wrote in my manifest, I wrote that I need a worker node that has a label disk SSD and memory high. So no node is making this statement true. So that's why it's in pending. And if you look into the describe pod hyphen and dev namespace. So you can see the scheduling is failed 0 out of 3 because I have 3 node cluster, 1 master, 2 worker are available. One node has untolerated taint, and this is and 2 nodes. Just yesterday we discussed about the taint. So master node is tainted. So that's why my workload cannot go to master node, and rest of 2 nodes are not tainted, but they are not able to fulfill the required labeling policy. So if I assign the same label on worker node, just like I label high memory to worker node 1, 2. Now memory high and memory high is assigned to both worker nodes. So now this worker node fulfill the requirement of our deployment that has disk SSD and memory high. So now you can see scheduler was looking consecutively for this requirement, and now requirement is filled, and all the pods are in running state. On worker node 1 it should be. Okay. So this was the scheduling based on labels. But we can make our label decision based on label with more expressive way. So if I again go to the same article, for assigning pod to node. So there is a concept of affinity and anti-affinity. This concept is more in depth. There are a lot of concepts associated. It is also making the decision based on label, just like we did. But we can make decision with more expressive syntax. Just like, let me, if I go to affinity and anti-affinity. Okay. So nodeSelector is the simplest way to constrain pod to node with specific label. Affinity and anti-affinity expands the type of constraints you can define. Some of the benefit of affinity and anti-affinity include, affinity mean the base decision will be made based on label, and anti-affinity mean decision will be made uh, if label is there, so it will not schedule there. Okay, and there is a concept of node-based affinity. Affinity mean attachment, you can say attachment. So node-based attachment based on label, and attachment based on the label assigned to a pod that is running on some specific worker node. So for example, one worker node has a database uh, pod, and I want to schedule all my database pod on that worker node. So in that case, I can use pod-based affinity rule to schedule all my pod to that worker node. So we will do this practical, you will get the better idea. So node-based affinity, when we will do, there is a syntax of required during scheduling and ignored during execution, and preferred during scheduling and ignored during execution. This is the hard rule, and prefer, this is a soft rule. The scheduler can't schedule the pod unless the rule is met. This function is like nodeSelector, but with a more expressive syntax. This, and for prefer during scheduling, mean when this will schedule the pod on some worker node. At that time, the label must meet the that exact as it is required. But ignore during execution mean if some pod is already running on some node, and you later on assign that policy, that will not affect the running pods. But any new workload will must comply with the policy, with the label. So in that case, if we set the required during scheduling, so that should match the label on the pod. But if preferred we set, then it will try to select that worker node. If that worker node is not available, it will schedule somewhere. This is a soft type of policy. So the concept of the syntax of the affinity is like this. I mean, affinity and node-based affinity, and we define our policy like this: required during scheduling, ignored during execution. And I mean, if the same thing that I explained you. And node selector term, how on what uh, rule based we can select the node. It is same like the label. And here it is a match expression, like this is the key and value, just like I select key disk and value is SSD. So here you can type disk and here you can type SSD. And you can again set something disk is equal to high IOPS. So here what they did, they label their uh, node uh, with the region where they hosted. If you want to run your pod on some specific worker node that is in specific region, then you can use this method. But anyways, you can assign any label to make this decision. Okay. And we will do this first very simplest form, then we will go to the complex syntax. So the simplest, I just made an example here. Under the specs section, either in the pod or in the deployment. We So I will just change this specs section under the specs, and before this container section. So specs section is in pod manifest 2. So if you are doing this for pod only, you can apply under the spec. So in the deployment, there is a spec section. So indentation, I just have to look into the documentation affinity and node affinity. The affinity is in parallel to, just indented. Node affinity. And then Weight we don't need. Weight we will I will explain you. So node selector term. Match expression, node selector term. Okay. So here I will type something like this, uh, disk, because I will not use memory, because memory high label is set to both worker nodes. So like disk in you can say just something like equals. I will explain you. You can type here multiple different type of operator, but in means equals. Okay. And this is the container, and this will made a decision based on disk is equal to SSD label on our uh, node based affinity rule. So I think I did specs, template spec, and spec. Okay. Yes, specs twice I type here. So I do need to delete this, and all the indentation will go one step back. Okay. kubectl get. You can see all are now scheduled based on worker node 1. Okay, so now let me, because the worker node 1 has a label disk is equal to SSD. Okay. Let me quickly do one more example. I will label uh, kubectl label node vu worker to uh, disk. Disk is equal to magnetic. So here I did disk is equal to magnetic. And if I modify kubectl get deployment, I think I can modify on the fly too. Get deploy, edit deployment in dev namespace with the disk magnetic. Okay, it's updated. If I get the pods, dev namespace, you can see all the pods are terminated and recreated to the worker node 2. So on the fly, I can reschedule all my workload to any other worker node. Okay. Yesterday we discussed about the drain. So you can think like this is a type of drain, but if you have multiple number of deployments, then this method will not work. But if you want to migrate all the workload to some specific worker node, in that case, you can use this method. Okay. So here what I did, I reschedule all my node based on the label. So how this is different than this method I use? I mean, this complex syntax also use the same thing. Either I use this way or either I use this way, both are same. I mean, I just need to provide the label. Here I provide the label. So if I go to the documentation, so here you can see uh, you can use the operator field to specify a logical operator. This operator field that I use in logical operator for Kubernetes to use when interpreting the rule. You can use in, not in, exist, does not exist, greater than or less than. So this is more expressive, but you cannot use in node selector. You can node selector is just like in is equals to this label should be equals to this. So if I use something like one more label I will do, label node worker one like uh, RAM is equal to 64. Okay, I provide a numeric value. So now I can make a decision to and worker node 2 to RAM just like 32. So one worker node has 64 GB RAM and 32. This is my own expression, whatever value I can set here. So my understanding is RAM 64 GB or and 32 GB. So now it has RAM 64 and RAM 32. Now let me try an example of greater than GT. I need RAM greater than 40 GB. On that node, it should be scheduled. So what I will do modification in my manifest, I will use here GT, I think G is caps. Yes, G is caps and LT is less than. Okay. So greater than I type, I will do RAM. I need greater than 40 GB. Okay. Any worker node that has RAM labeled to greater than 40 GB, it will schedule there. Let me just delete this deployment. Mm, There should be other type of changes too. I think I need to just let me check some other example if they gave here. I don't think so. There is some example of greater than. Actually, I did a syntax mistake. Label selector. It's a pod based. I need a node affinity. Let me try this one. Node selector term match expression and key and value. Operator, I will use GT. Key RAM value 40 GB. I can directly assign, or I need to do indentation, I think. Cannot be handled as a deployment. JSON cannot. I'm using some wrong syntax. Its syntax is different. So let me just take a look on. I know I need to look this syntax. I don't know exactly. And there is one mistake I did. Actually, there is no example given here for the greater than. Or whatever, if we use, I use n, I can use not n exist.
We can use in. And this will check the available RAM or next
No, this
or
is
the
just
RAM.
a label-based decision.
Okay.
It's not checking the actual RAM. I just assign a label, random label. Okay, just I will check this, but let me check this now. Uh, pod-based affinity. So there is a concept of pod affinity too. For example, if I explain you in the form of, for example, these are three worker nodes and they are labeled. But you don't want to make a decision of a scheduling of a pod based on the worker node label. The pods running inside your cluster, different pods are running, okay? And each pod has its own label, just like its label is uh, app is equal to web. Okay, its label is app is equal to web. Its label is equal to app is equal to uh, app is equal to, for example, any application, just like CSM, the name of the application. Any label we can assign, and it has label app is equal to DB. Okay, and it has a label not app anything we can say, just like uh, uh, so key value we can assign any key value when we will deploy the pod. So for example, just think like these pods we have, and these pods have these labels. I have not assigned label to these one, but just think like this is worker 1, 2, and 3, and different pods are running, and different pods have different labels. Now I am going to schedule a new pod, and I want to make a decision based on the label of the pod. Mean, schedule this pod on some worker node where pod already running with purpose is equal to compute. Then this worker node will attract this pod. And if I make a affinity rule of pod-based affinity rule that I want to schedule this pod where already an existing pod is running with app is equal to CSM, then it will host here. Okay. So why we are making this type of policy? Because we want to uh, mm, we want to make the collection of all running pods on same worker node where a specific type of applications are running. So in that case, we don't need to make any just we have to define our affinity rule, and all the pods will be attracted by the other pods. Okay, so all web type of pod will collect on one worker node. All DB type of pod will be on the one worker node, and all compute type of pod will be on one worker node. Similarly, there is pod anti-affinity rule. There is no node anti-affinity rule. There is a pod affinity and node affinity. Node affinity is based on the label of the node. Pod affinity based on the label of the pod. Affinity mean attraction. The pod will be attracted to that worker node where that label is available. And when we will do the pod anti-affinity, so we will define a rule, never schedule this new pod on the worker node where already the pod is running with app is equal to DB. Then it will be repelled by this worker node. It can be scheduled anywhere, but not here. Okay, so this depends on the scenario, on the requirement of your application, or the architecture of the cluster you want to design for different application. I mean, you want to make your worker node for specific type of applications. So this pod affinity and anti-affinity rule is very useful in that case. So let me